All right, hopefully you've watched the first part of 21E. This is the second part where we're doing the same exercise, but we have a quadratic over a quadratic. The questions are the same, so we're going to go through the same process. I like to factor this. So this is x minus 2 times x minus 1 all over x plus 2 times x plus 1. All right, so there's my factorization. That helps me figure out some of these. Vertical asymptote, I'm setting the denominator equal to 0. So there's my factorization. Setting it equal to 0, that means that x will either be negative 2 or x will be negative 1. So I'm going to have two vertical asymptotes again, just like in the first example. And they're pretty close together, so I'm going to have to be careful how I graph. My horizontal asymptote, this is middle heavy. The degrees are the same, so I'm going to divide the lead coefficients. 1 divided by 1 is 1. So I have a horizontal asymptote of y equals 1. Here's my derivative. I got it by doing quotient rule of the original function. The derivative of the top is 2x minus 3, which is right there, times the bottom, which is right there, minus the top, which is right there, times the derivative of the bottom, which is 2x plus 3, right there, all over the bottom squared. And I factored my denominator before I squared it, and I squared each of the factors. All right, now what I did then is I expanded everything out and factored it as much as possible, and I got 6 times x minus root 2 times x plus root 2, and the denominator stayed the same. So that's my first derivative. When is that equal to 0? Well, 6 is never equal to 0, but x minus root 2 is equal to 0 when x is root 2, and x plus root 2 is equal to 0 when x is negative root 2. So those are my stationary points. And I would probably want to plug them into the function and get some y values, which don't turn out to be very nice. All right. So let's look at what's going on. I have my vertical asymptotes. Let me draw those in. I have my vertical asymptotes at negative 2 and negative 1. And then I've got my stationary points at x equals negative root 2 and x equals positive root 2, which is about 1.4. That's why I've kind of put them where they are right now. So let's look at what's going on before I get to negative 2. Let's try a number like negative 3. Negative 3 minus root 2 will be negative. Negative 3 plus root 2 will be negative, and just like the last example, the denominator is going to be positive all the time because it's being squared. So it looks like I have a positive first derivative everywhere here, so the function must be increasing. Okay. Looking between negative 2 and negative root 2, so let's try a number like negative 1.5. All right, well, negative 1.5 minus root 2, that's still negative, but negative 1.5 plus root 2, that is still negative as well. It's yeah, the negative 1.5 is a little bigger than the root 2. So this is going to stay negative. Denominator is always positive. So the first derivative is positive again. So it is increasing between those two numbers. Then between negative root 2 and negative 1, let's try a number like negative 1.2. This will still be negative. This will become positive because the root 2 is now a little bigger than negative 1.2. So it looks like the whole first derivative is going to be negative. And so the original function will be decreasing there. All right, looking between negative 1 and root 2, let's try a number like 0. 0 minus root 2 is still negative. 0 plus root 2 is still positive. The denominator is always positive. So this whole thing is negative, meaning that the function is decreasing everywhere between negative 1 and positive root 2. Then after root 2, let's try a number like, I don't know, 5. That's going to make this positive. Everything else is going to stay positive. So this will be positive, meaning that the original function is increasing everywhere from root 2 to 5. All right, then we find our intercepts. There's our original function again, factored. And to find my intercepts, to find my x-intercept, I'm going to set the function equal to 0. And a fraction is equal to 0 if the numerator is equal to 0, but the denominator is not. And that happens at x equals 2 and x equals 1. To find the y-intercept, I'm going to set x equal to 0, so that's going to be negative 2 times negative 1 over positive 2 times positive 1, and that's going to be 1. So I have a y-intercept of 1. Alright, so there's my summary again of everything that I've already talked about. I'm going to graph it a little bit at a time, starting with the horizontal asymptote at y equals 1. So that is right here. I am increasing before I get to x equals negative 2. So I'm going to just draw a little up arrow before I get to x equals negative 2. There is a vertical asymptote at x equals negative 2, so let me draw that in. There's my vertical asymptote. And it is increasing everywhere between x equals negative 2 and x equals negative root 2. I'm going to have to be careful here because it's just kind of increasing a little bit there. And then I get to negative 2 comma negative 33. Alright, well, I don't have negative 33 on here, so let me change my scale so that the y-axis goes up and down by 5s. So that's a negative 5. Each space is going to be a negative 5. So that's negative 5, 10, 15, 20, 25, 30, 33.9 would be right about there. But that's not where that point goes. The point goes at negative root 2 and that. So right about there. Okay, so it's going to be increasing before it gets to that point. It is going to be decreasing between that point and x equals negative 1. So it's got to decrease just a little bit before I get to x equals negative 1. Then I've got another vertical asymptote at x equals negative 1. So let me draw that in. Not a lot of space to draw a graph in there, but I'll make it work. Alright, then I am decreasing everywhere between x equals negative 1 and x equals root 2. So let me draw a little arrow between those. Yeah, that's about right. And in there I've got a y-intercept of 0, 1. And I've got an x-intercept of x equals 1. Is that right? Yep. Got a x-intercept of 1. All right, and then I have a local minimum at square root of 2 and negative 0.029. So at about 1.4 and a little bit below that. Okay, there's my local minimum. Then I am increasing everywhere after. And I have another x-intercept at 2. And I'm still increasing after that. And I have my horizontal asymptote again. All right, so everything's been taken care of. This first part, I think, will have to go in here. It looks something like that. Then, in between these two asymptotes, I've got to increase, I've got to decrease, and I've got to hit that as my maximum. So it's going to go, this is going to look terrible, but you get the idea. Okay, it's going to look something like that. And then after this second asymptote, I'm going to have to decrease, hit that y-intercept, hit the x-intercept, hit the minimum, and then I've got to decrease or increase after that minimum, come back up, but do not cross the horizontal asymptote. So there is the second example. You could check that on a calculator just to see what it looks like, but it's going to look very, very close to this. So make sure you watch part 3, and then you'll be ready to take your quiz.